Hey guys, I am Gautam and welcome to Chemics. So in this video, I will be solving all the question papers, all the JAM 2020 question papers, that is from 1 to 60. Okay, question number 60. I will be solving all those questions in this video. Okay, you will not find any video on YouTube or anywhere else the all solutions. Okay, all the solutions from 1 to 60. So just watch the video carefully. But before I start, I just want to tell you, if you are preparing for JAM 2021 exam, then you should fill one form so that I get to know that whoever are preparing the JAM 2021 examination. I can help them. Okay, I can guide them. Okay, so just for that, just do check the description and you will find the first link. Okay, over here, just fill the link. Okay, this is the Google form. So just fill the form, then I will get to know whoever are preparing, and then I can guide you whole year. Okay, so whatever, let's start this video. So let's talk about the first question. Okay, so I'll be discussing the MCQ questions first. Yeah, so the first question about the R configuration. So as you have seen that on R configuration, it's very easy question and common question that every year you can find this kind of questions. That is you just have to learn these things. Okay, and at the same time I will be showing you that what are the questions that those are directly coming from my materials. That also I will be showing, so that you can get idea that whoever are preparing with my material, okay, whoever has taken all those things and whoever are thinking to take the material, then they can get the help. Okay, that they can choose right one. Okay, so the first question, that is RS nomenclature. So this question you won't get any common questions, but in every in my material there is at least 50 to 60 questions RS nomenclature. So if you can solve all those questions, if you have practiced all those questions, then you can easily solve those. Okay, so this is the first answer. So the answer will be B. So I am not discussing this because it's a general questions. Okay, most of the students can solve this question. The second question, of course, yeah. So the salt bridge is a galvanic cell that allows the flow of, yeah, the option will be ions but not electrons. That is, salt bridge allows the flow of ions, that is Na plus, K plus, like that, but not the electrons. Yeah, that's true. And this is the screenshot of my material. Over there you will get the answer. Okay, so if you read these things, you will get the answer. Okay, you will get the answer. And remember one thing, listen one thing very carefully, that in JAM, what happens, whatever you know, whatever knowledge you have, you just to fit your knowledge to the questions will not fit your knowledge. Remember this thing, because whenever I will solve all those questions, this knowledge, this note will help you a lot. Okay, because you won't get any kind of common questions, that 100% questions that will be coming from whatever you know. Okay, whatever you know, you just have to fit that knowledge to the questions. Okay, so take care of that. So I have given the screenshot, so pause the video and read all those things. Okay, third question, treatment of formic acid with concentrated sulfuric acid. Okay, this is a very general questions, and this is a remember based questions. Okay, memory based questions. So no one can expect this kind of questions. So that was just no common questions. That means H2SO4 HCO formic acid reacts and gives CO and hydrated H2SO4. That means H2O will form. Okay, in this reaction. That's why CO and H2O, right? Then the d orbitals involved in the hybridization from square planar and trigonal pyramidal. Okay, so that means d orbital in the okay, the most d orbital, those are participating in forming these orbitals, these square planar and trigonal bipyramidal geometry. So square planar means this kind of dx square minus y square orbital directly interact with that, and of course TBP, that is trigonal bipyramidal, means this dz square orbital directly interact with the ligand. Okay, so that's why dx square minus square and dz square will be the correct answer. And I have shown you this screenshot of my material, so you can see that this TBP dz square and this is square planar, that dx square minus y square. So you just have to get the idea that I have told you, that you just fit your knowledge with the questions. Okay, so that you have to take care of. The next question, that is about the radical chain reaction. So it's a very common reactions that you can find, of course, in my materials also. So that will be the step 2 and step 3, that is chain propagation. Both are the chain propagation reaction. Okay, I have selected the wrong one. That will be C, chain propagating and chain propagation reaction. Okay, so that one. Then the graph, that is TS diagram, temperature entropy diagram. Okay, so that will be this, and I am not explaining all those things. If you want to learn anything, just pause the video and see whatever is in the page. Okay, so that is about TS diagram, and this is the screenshot of my study material. So you can find that same question directly came in JAM. chemistry examination. Okay, the next question is the nucleobase not found in DNA. Of course, you know, it's a very common question, biology question, that is uracil. That is also in my material, the screenshot of my material. Then the next question, that is the products of the hydrolysis of calcium phosphate. Okay, whatever calcium phosphate, that is Ca3P2, when hydrolysis with water, that is we will get calcium hydroxide and phosphine. Okay, the answer will be phosphine. So this is also a memory based question. If you don't know, then you can't answer these questions. Okay, so nothing to explain over here. Then the correct order of boiling point. So I am so boiling point, that means the system which will have the more surface area. You can see the surface area will be more, the boiling point will be more. Okay, so the system that has more linear branching means this is more linear, that will have the more surface area, and that will have more boiling point, the system will have. Okay, that means one will have much more boiling point. Then of course coming it is a ether, symmetrical ether, that is it has no dipole moments. Okay, along with the surface area, dipole moment is also important, because it's OH group, that means hydroxyl group, alcohol group. Okay, those are really can form hydrogen bonding like things, and van der Waals attractions are really important. But in case of ether, there is symmetrical, that means there is no dipole moment in this system, that is it will have the lowest. So you get the highest because of the surface area, and you get the lowest. So find the option which will have the highest one and lowest two, that will of course C, and then you can match your answer with 2 or 3 and 4. So this is the elimination type method. Okay, because you cannot, you need not to get the idea of 3 and 4 where they will okay stay, right? So you can just get 1 and 2. 1 is the maximum, 2 is the lowest. So C, 1 has maximum, 2 lowest. Okay, of course D is also possible, but then you have to so as D is also possible, so then you have to look at 3 and 4. That means 3 and 4, in between 3 and 4, 3 has the more surface area, this is more linear, and this is less linear. Okay, that is surface area 3 has more boiling point, that is 3, then 4 has less boiling point. Okay, so option C will be correct. Then the question is the correct statement for the following sequence. Okay, of course it will be a constitutional isomer, that is the bonding connectivity, that is option D is correct. Why? Because the bonding connectivity, remember this one, resonance is not possible, because here pi bond delocalization is not possible. Okay, that's why bonding is the hydrogen, the attached hydrogen are different in these three systems, because here hydrogen is connected to nitrogen, here one with carbon, here another nitrogen and another carbon, and here two carbon, hydrogen is connected to one carbon atom. That means the bonding connectivity of hydrogen atom are different, and if bonding connectivity are different, then those isomers are called constitutional isomers. Okay, so option D will be correct. Then the number of bonding. Okay, so it's a very easy question. So it is UHF, so frontier molecular orbitals. If you don't know frontier molecular orbitals, that is the number of lone pairs in the system. Okay, so 1 2 3 lone pairs, that is total electrons will be the number of electrons, that means 6. Then the question is determinant. So I am not solving this, so just to solve the determinant, then you will get the answer. Okay, just pause the video and you can see, you can check. Okay, then this is very important question, that is the boil temperature TB is defined as the temperature at which the properties of real gas coincides with the ideal gas. Okay, so at low pressure limit. Okay, that means they are given they have already given the answer. How? Listen, you can see the dotted line means the for ideal gas. So if any line comes through this dotted line, that will behave like ideal gas. So at low pressure region, this is x-axis denotes the pressure. So at the low pressure region, only this graph will coincide with the dotted line. That means this graph will show at the low pressure region will show ideal behavior. That's why answer B is correct. At low pressure, real gas behave ideally. That is what is given in the question. Okay, so the answer is given in the question paper, so you just have to be a little bit smart to answer this kind of questions. The major product form in the reaction. Okay, so this is a very iodolactonization question, so you can see the mechanism. Okay, I'm not explaining all these things. Okay, but here I will just explain the difference between this and this. Okay, here iodine, first iodine is attacked normal manner. Okay, like this. Okay, here is no above below section, but when this COOH O minus will attack to this center cycloiodinium ion, okay, system, then this iodine will change its stereochemistry. Okay, and it will go to the below, and this will be above section, like, because this is a SN2 type reaction. Okay, as this is SN2 type reaction, that means this will change the stoichiochemistry of the iodine, and it will be opposite to the stoichiochemistry of iodine. That is, it is below, it is above. So it comes from the above section and makes the iodine to the below section. That's why option B is correct, right? Then the MC bond strength. Okay, so MC bond strength totally depends upon the metal charge density, negative charge density of the on the metal ion. So here titanium, that is 2 negative minus. Okay, CO is neutral ligand, that is titanium 2 minus, cobalt minus, chromium 0, and manganese plus. So metal that will have the more negative charge, that will donate more electron to the carbon. So if it donates more electron to the carbon, then the metal carbon bond will be stronger than the others. That's why titanium 3, then 4, then 1, then 2. Okay, 3, 4, 1, 2, option C correct. Okay, then I am getting, it's a VSBR theory problem. So Br3 plus, that is like this, and this plus means one less electron in the central metal atom. So bromine has 1, 2, 3, 4, 5, 6, 7 electrons, sorry, and if there is 1 plus, that means 6 electron will be there. So 1, 2, 3, 4, 5, 6. Okay, and bonding is like that. That means 2 lone pair will be present. 2 lone pair means this may be a of course they are asking for geometries, so that means it will be like that. Okay, tetrahedral like shape. Or Br3 minus, so 1 electron extra, that means here will be the 7 electron and 1 extra electron, that will be 8 electron. That means after bonding with 2 bromine atom, the central bromine atom will have 3 lone pairs. Okay, that means it may be the TBB like structure. Same is true for Br3. Okay, so this example you will find directly from my material. Okay, the Br3 like this example. So by elimination method you can discard all those things. Okay, so this is quite easy. Okay, this is quite easy.
The next question is about the coordination chemistry questions, and the number of DD transition in that complex, that is CO2 plus complex, will be 3. The one, this is not the correct answer, the answer will be 3. Okay, and this can be explained by the different diagrams like Russell center couplings and of course Orgel diagrams. Okay,
material, and then the rate of hydrolysis from 1 to 4, that is about this. So you have to get the stability of the carbocation. So I have just done it, that the step after releasing the Br minus, the carbocation. Okay, so if the carbocation is stable, the rate of hydrolysis will be higher. Okay, so this carbocation is not stable because of the position of the preset, position of the positive charge on the preset position. Okay, in the preset, then this is stable. Okay, plus R and plus I effect. This is anti-aromatic, not that much stable. This is aromatic, most stable. So 3, then 2, then 1. Okay, that is little bit stable, but 4 anti-aromatic. So this will be the correct answer. Okay, so if you may be confused between 4 and 1, but what you need to do, find the option that will have 3 and then 2, 3 then 2, 3 then 2, 3 then 2. There is only odd option left, so you can select by this method. Okay, then this is a very common reaction. You can see the mechanism. Okay, this is first is the ethyl, that is the Grignard reagent reaction, and then it will be Wittig reaction, and in between that there is oxidation type reaction. Okay, that ET will OH will be shifted like this. Okay, then it is a very easy question. You just have to get the paramagnetism or diamagnetism behavior, magnetism behavior of the Ap2 plus high spin and Ap2 plus low spin, because you know in deoxyhemoglobin Ap2 plus stays in high spin state, and in oxyhemoglobin Ap2 plus stays in low spin state. That's why D6 system and D6 system is paramagnetic because of high spin, is diamagnetic because of low spin. Okay, so that's why if you know that generally Km, that means molar susceptibility versus temperature graph for paramagnetism is like that. If you multiply it by T over here, Km T, then with this T, this system, this will also increase after multiplying with T. So that graph will be changed to this parallel to the x-axis. Okay, that means for paramagnetic systems the graph will be x-axis. For diamagnetic system, these changes will be very little. That means paramagnetic system, paramagnetic plot will be they have shown that the solid, paramagnetic, that means high spin state, high spin, that means deoxyhemoglobin, that means deoxyhemoglobin dash line. Okay, that is paramagnetic. That's why paramagnetic lines are above than the diamagnetic line. Okay, this is the explanation for that. The major product formed in the following reaction is, okay, so this is a very common reaction, this Favorsky reaction. Okay, you can see the mechanism, and this kind of example likely to be same. I think Br and two Br atom may be different. Okay, just Favorsky reaction mechanism. I'm not explaining this. The same similar like mechanism is present in my material also. So I have given one example. These other examples, of course, there are a lot of examples over there. Next question is coming from the coordination number of aluminium ion and the number of breaching. Number of breaching hydrogen atom is okay. So you can just get the PDF of these all these things. Okay, if you want to interest to get the PDF of this whatever I am teaching or whatever I am solving this. Okay, so you can get everything in the description. So check the description, you will get the PDF of today's videos. Okay, so this is the link of that of the structures. Okay, because I am getting from a publication, that means American Chemical Society paper, but this kind of question you may face because they will not allow you to get 100% marks in IIT JAM examination. So that's why this kind of questions they might have asked. Okay, so that the answer will be 8 and 8. Okay, you can see the image, you can see the picture of that system. Okay, the most stable species in each pair of conformers. Okay, so first 1 or 2, in between 1 and 2, 2 is in 2, the bulky group is in axial position, so 1,3 diaxial interaction will be present, so less stable, that is 1 is more stable, right? So 1, so you just find the option which will have 1, so option B and D. So you can eliminate these 2, A and C, okay, in the initial stage. So you just have to find the correct option in between B and D. Then 3 and in between 3 and 4, if I can't explain this 4, why is that? Okay, but I can explain 5 directly. Why? How? There is a lone pair of oxygen and these oxygen and these carbon, all these are in the same plane. So this lone pair and this hydrogen, this can form hydrogen bonding, so that's why 5 is more stable. So 5 is more stable, that means 5, yeah, not D. So option B is correct. So if you don't know the correct option in between the 3 and 4, okay, then also you can choose the correct answer. Okay, so this kind of hydrogen bonding. Okay, so this kind of method is called elimination method. So you are eliminating 1, A and C first, then D and in your last stage. Okay, so the next question, the major product formed in the following reaction. So this is the McMurray reaction, so they use the McMurray reaction and then the hydrolysis like things. Okay, then Keto-Enol Tautomerism. Okay, so you just have to allow two concepts. McMurray reaction, that is present, yeah, this is the example of McMurray reaction. The mechanism is also present in my materials, so you can use that, and then Keto-Enol Tautomerism. Okay, you can select this by seeing the options. Okay, because you have to get the keto group, that is after getting the alcohol you have to find the keto group. Okay, so this is a very common reaction. Next question is, okay, it is very easy question that I have already solved. Okay, I'll be showing you the section in my material. So they are asking about, they are given is 35Cl fundamental vibration peak transition. You don't need this, right? They are just want to they want to just confuse you. That's why they are given this kind of thing. They have given this kind of things. Okay, so whatever, let's talk about the solution. So you know that for vibrational system, vibrational spectroscopy, from quantum mechanics we get the energy of the system is, or energy of the pth state is h p plus 1 by 2 and omega over osc. Okay, p is the vibrational quantum number. So if at b equals to 0, we get E0, that is called 0 point energy. So E0 equals to, if we put p equals to 0, we will get the equation, and omega over osc, that means 1 by 2 pi c k by mu. Okay, so you just have to get the E0 is 35Cl, and E0 D35Cl. Okay, so now I am just comparing all these things. Okay, so epsilon 0 is 35Cl and epsilon 0 D35Cl. So I have just put all these values. Okay, so I have put this, then I have put this part, and this part will cut, half h cut, okay, half h, then omega over OSC I have put the values, okay, over there. And after putting the value, just they have already told you that the force constant will be same, that is kk will be same. So this part will cut, kk will cut, then I will get only these values. After putting this mu, that is m1 m2 by m1 plus m2, okay, the reduced mass equation, I will get this, and after calculating this I will get 1.395. so this option will be correct. So the very basic concept we have to apply. Okay, and this section you can see this is not the exact image. Okay, so this section you just have to apply this section, that is a screenshot of my material, so you can get that. The case type structure adapted by boron hydride. Okay, so B5H11, right? So find here, this is the screenshot of my material. So B5H11, the arachno series 4n. Okay, BN is n plus 6. So this is also directly came from a material. So another section, okay, this is a very common question, the gas, liquid, solid. So this is thermodynamic question. So I'm not explaining this because this is a memory based question. If you don't know, then you can't answer this question. Okay, this thermodynamics based question. You can find these kind of things in my material also. So this is a Diels order reaction. Okay, so remember this one. They are asking about the activation barrier. Okay, the activation barrier, because the reaction which will occur very feasibly, then that reaction will have less activation barrier. Okay, so the highest activation barrier will have the highest activation energy. Okay, that means the reaction will be easily favorable. Okay, that will have the least activation barrier. So find that one. So here you can see number one, which will have nothing is there. Okay, so this is a system. Okay, and this double bond is localized. This cannot be delocalized. Okay, because the resonance is not possible over here. That's why in this system, okay, you can these two double bonds is in the C-joint position, and you can get the product like this. Okay, with that with these two double bonds. But here oxygen, nitrous, alpha, and NH bond. So each has what happened, the lone pairs. Okay, and because of that lone pair, resonance generally occurs. So this double bond is easily delocalized. So if the delocalization increases, then this localization decreases. That means double bond is not present right over here. So reaction will not be that much feasible. So in these three system, the system which will create less delocalization, that means the resonance will be less in the system. That system will have less activation energy barrier. That means oxygen, that is more electronegative, so it will not donate the electrons to the system. That means the double bond, that is two pi bonds, will be localized in that position more than the sulfur and nitrogen. So oxygen, because of this higher electronegativity, this will have the more reactivity. Okay, so because of that more reactivity, the activation barrier will be less. That's why first one has least activation barrier, then 2, then 4, because then nitrogen is coming, and sulfur is least electronegative in between oxygen, sulfur, and nitrogen. That's why I have to written over here that less delocalization will create less activation barrier, because to react in the Diels order reaction, the reactant, this diene system, should have the localized double bond, localized pi bond. Okay, 2 pi bonds, right? So okay, that's why option C is correct. This is the answer. Okay, so you have to get that option, that you have to get that concept. As I have told you, you have to clear the concept, then you have to apply that concept in the questions. So this is my question, materials screenshot. Okay, so you can find the activation, this section, okay, that which will have the highest resonance energy. This will have lowest, then this, then this. Okay, lowest resonance energy means this is not easily resonatable. Okay, so sulfur will easily resonate this, its lone pair, then nitrogen, then oxygen, because of the highest electronegativity of the oxygen in among these three. Okay, then yeah, of course, solid line. Okay, so you have to know the HF normal bond length, that is about 95 pm, and HF hydrogen bond length is 155 pm. This is and the hydrogen and the solid, in solid state, the crystal will be in zigzag manner. Zigzag means above below, like these things. B, C, D all are in zigzag manner. So HF, that is bond length, will be less, and H hydrogen bonding will be higher. So option B will have HF bond length less and HF hydrogen bonding will be higher lengthy. Okay, so that's why option B is correct. That it is also a memory based question, so you can't explain, or you can't no one can expect these kind of questions. Okay, so the complex which will not obey 18 electron rule. Okay, so I have shown you that this will obey 18 electron rule, and this won't, because you just have to get the from 18 electron rule, you just have to get the number of electrons are donating, which are the systems, and the number of electrons, which systems are donating 2 electrons, which systems are donating 3 electrons. Okay, so you just need to know that the number of electrons are donating by the systems. Okay, so I have shown you that eta 5 Cp minus 6 electron, Ru3 plus, okay, 5 electrons CL dot, and I have done one rough calculation, and it's not following the 18 electron rule. Then I'm coming to MSQ type questions. So the first question is about this, and I have shown you all this. So see, this will be the correct option. I have shown you mechanism. Okay, and this A won't give the product, B won't give the product, C won't give the product. So I have shown you all these things. So pause the video and check the mechanism. Then achiral stereoisomers. So remember, this question is, you have to look at carefully at these questions. Okay, because achiral stereoisomer, that is chirality is not present. Achiral means no chirality, that means this will have chirality, this will have chirality. Okay, axial chirality, this will show. So this to have the sigma plane. Okay, sigma plane over here, sigma plane like this. So as the system has sigma planes, that means this will be achiral. Okay, that means, and general chirality is not possible, so achirality is possible. Okay, so C and D will be the correct option. Then yeah, this is a very basic concept from quantum mechanics, that is psi describes the wave function of a particle, the probability of finding a particle in that section. Okay, so they are not asking about minus infinity to plus infinity, they're just asking about the probability in that section. That means that maybe if the system is real, that is psi square, if the system is imaginary, then psi star psi. Okay, and dx dy dz dx dy dz, here it's not correct because they are giving the domain minus infinity to plus infinity, that's why it's not correct. Okay, okay, you just need to write the formula of these, all those four options, A, B, C, D. So you can see that to be organometallic, there should be a metal that is connected to the carbon atom. So here oxygen is connected to carbon, here nitrogen is connected to carbon. Here only option, in case of option A and option D, metal is directly connected to carbon, or carbon is directly connected to metal. Here carbon is connected to copper and carbon is connected to magnesium. That's why these two A and D are organometallic reagents, right? So then okay, so to get this, you have to find the sigma plane and you have to find the two different kind of hydrogen atom. How? 1 2 3 4, one type of hydrogen atom, and these are symmetrical. Okay, so that means these and these will have second type of hydrogen atom. So two type of hydrogen atom to get two signals. The question, read the question carefully, you just need to read two signals, right? Okay, so this will give two signals, and here also this you will get two signals. Two types of how? 1 and 2, and same is this, and this is equivalent to this, chemical equivalent to this, and this is chemical equivalent to this. That means 1 and 2 types of hydrogen are present in this system. 4 types of system you will find. Okay, because one type of second, third type, fourth type. Okay, 1 then 2, then 3 type of hydrogen present. So you will not get 2 signal, 3 signal, 4 signal you will get respectively, right? So that's why C and D are correct options. So again, you have to same questions. 3 signals. To get 3 signals, 3 different kind of hydrogen should be present. 1 2 3, 1 2 3, 1 2 1 2. Okay, remember this one, 1 2 1 2. That means this is symmetrical system, that is this is equivalent to this is equivalent to this. So these are not different. Here also this CH is equivalent to this, so those are not equivalent. Okay, those are chemical equivalent. So one type of, here also two type of. So to get 3 signal, 3 different kind of hydrogen should be present. So here 1 1 2 and base 3, 1 2 3. Okay, so that's why. Yeah, then it's also very easy question. All the 4 options will be correct according to IIT JAM website, because I can explain this. Suppose initial state was unfolded, final state was folded, UFF. Okay, the picture is like this. So delta, for a spontaneous process, delta S should be greater than 0. That means delta S should be positive. That means F final state minus initial state will be positive. If delta is equals to 0, okay, then what will happen? Then delta G equals to delta H minus T delta S, that will be delta H, and they have told you that H unfolded state will have much more delta enthalpy than folded state. If delta S equals to 0, so delta G equals to delta H. So delta H means delta H minus delta UF. So UF is greater, H UF is greater than HF. That means this value will be negative. So delta G will be negative. That means system is spontaneous. Okay, so if delta S equals to 0, that then also system will be spontaneous. So option B is also correct. And you can see that the system will occur, this folding will occur spontaneously if entropy increases. I have told you, okay, from the second law of thermodynamics. That means their initial state was unfolding and final state was folding. So unfolding to folding, if entropy increases, okay, then system thing will be spontaneous. That's why final state is what happens, the entropy of the folded state is much more than the unfolded state. Okay, then folded minus unfolded, that will be positive, that is entropy is increasing. That's why it will be spontaneous. Okay, the process will be spontaneous. If delta S equals to 0, that means delta folded and unfolded will be equal. okay, that I have already explained you. And if delta S unfolded is equals to 0, that means delta ASF will be positive. Okay, positive, that means the system will the process will be also spontaneous. And finally, last option, option D. So delta G equals delta S minus T delta S. Okay, so if delta G is negative, that is less than 0, system will be spontaneous. You know from thermodynamics, that is delta H minus T delta S less than 0. Okay, if G is less than 0, okay, delta G is less than 0. So this I have just put the value. Then I have just done normal mathematics. Okay, then I have calculated delta S value. Delta S greater than delta S by T. Delta S greater than delta S by T. So option D is also correct. That's why all options are correct in this question. Yeah, then the soft bases. So you can see I minus CO minus CO H minus I minus H minus CO. This is the screenshot of my material. Okay, you just have to explain this from Shaft principle. So this is a very easy question. So it's HTNC. This is also very soft basis, right? Then I am getting this again. Okay, so this is, you have to find the system which will show 0 dipole moment, 0 magnetic moment, and CFS value this. So if any of the system doesn't follow any of these, okay, any of this option, that is 0 magnetic moment, 0 dipole moment, or CFS value this, then the answer will not be correct. So let's take first one. So this one will have, will not have, you just have to find at least one condition that if it doesn't follow only one condition, then it will not be correct option, right? So here manganese MnCO whole 5 CH3. So this, you can see that if you can draw the system, then CO5CO system and 1 CH3, that is the dipole moment won't be 0. That means dipole moment won't be 0. That's why it's not selected to be correct answer. If you take the second, okay, this one, okay, second one, then you will get 3D8 system. So if you get 3D8 system, the electronic configuration will be like this, and CFS will be minus 1.2 delta 0, but they are asking about minus 2.2 delta O. So option B is also not correct. Okay, if you go through the option C, then trans system, that is of course dipole moment will be 0, and if you get all these things, then you can get the CFS is this. Okay, just do normal mathematics, and to get that, just check my material. Okay, and option D is also same. Okay, I'm not explaining this, just pause the video and see whatever I have done calculation. Okay, yeah, this is a very important question, and the concept you have to apply here is the concept of conjugative reaction. That this is the screenshot of my material, so you can see the emails. Okay, those are quite similar. Okay, so let me explain this. So from R to S, K1, that is the when S is forming, that is the rate constant is K1, S to K3, R to Q, K2, Q to P, K4, right? So now the product, the reactant is R, that means every time its concentration will decrease. So as R, it's decreasing, and they have given the rate, different rate is proportional to rate constant, so they have given the rate, okay, different rate. This is for Q, this is for P, this is for S. So at with the change of time, if the concentration is more for a system, if P or Q, any system for any intermediate, if that has more concentration, that means the formation rate is more for that intermediate. So let me explain this, why I have chosen A, B, C. K2 is greater than K4. K2 means formation of Q, and K4 is formation of P. So formation of Q is greater than formation of P. How I am getting this? So formation of Q, that means you can see that this at lower time, the concentration of Q is more than the concentration of P. Okay, that's why Q is forming more. The quantity of Q is more than P. Okay, that's because of the rate of formation of Q is greater than rate of formation of P. Okay, that's why K2 is greater than K4. Similarly, K3 is greater than K1. K3 means the formation of P, and K1 means formation of S. P and S. So P and S. So you can see that P is above. Okay, the P is present in the above section and S in below section. That means concentration of P is every time concentration of P is more at any time than the S. That means formation of rate of P is greater than formation of rate of S. That's why K3 greater than K1. Similarly, you can explain the K2 greater than K1. K2 means Q and K1 S. Q and S. Q and S. Q and S. Q is in the above section, S in the below section. course concentration of Q is more, that's why K2 is greater than K1. Okay, so and these cannot be equal. If they are equal, then line should be same, but this is not possible. Okay, so this is the concept. Okay, if you understand this concept, you can easily explain, you can easily solve this kind of question. This is the screenshot of my material. Now coming to NAT section. Okay, so the first question, just see the question, you just have to differentiate this, and that should be 0, and to get the maximum or minimum value. So they are asking the maximum value, that means you will get the maximum value. Okay, so you have just answer will be 6. Okay, just pause the video and see the answer, how I have solved this. Normal mathematics just. And this question I have already told you in my live session that this kind of question you will face, maximum minimum. I have told you again and again. So this question you have already faced. Okay, so it makes me happy. So whatever. So the next question, the total number of isomer. Okay, total number of isomer COEN to Cl2. So I have shown you that is the C is the mirror image 1, 2, 3, and second one will have the only mirror image is, total will be 5 answer. Okay, and the same example I have shown you, same example, COEN to Cl2 plus, COEN to Cl2 plus, this one same question in present in my material, and second is COEN whole thrice, COEN whole thrice, COEN whole thrice. Okay, so it also makes me happy. The same question directly came from my material. So the next question, the number of constitutional isomer. As I have told you, 2 questions came from constitutional isomer concept. That is the number of, in trimethyl cyclohexane, the number of constitutional isomer possible. So 3 methyl groups are present. So you just have to put the 3 methyl groups in different ways. So 1, 2, 3, 4, 5, 6 I have put only. You don't need to do above axial, equatorial, above below section. Okay, nothing to do, because they are just asking about bonding connectivity. As I have told you, difference in bonding connectivity only, not above below. Like those are not don't explain the difference between the bonding connectivity. Okay, so I have just put different possibilities, and I have got the 6 answer, right? And that is correct. Next, fluorine. So this is solid state mathematics. So you can see the picture, pause the video and see the picture, that you just have to find the lowest distance between 2 lattice points. So for FCC, the lattice points are present at the corners and also center of the face. Okay, so the lowest distance will be center of the face and the corner, this difference. Okay, the smallest distance, that will be half of the diagonal. Diagonal means a root 2, a is given 14.1 Armstrong, put the value and get the value 9.98 or 10 Armstrong. Then the same question is okay, the maximum longest wavelength, that means longest wavelength, that is E equals to AC by lambda, that means E is proportional to 1 by lambda. To get maximum wavelength, energy difference should be lowest. So to get the lowest energy difference, transition should occur between 1 and 2. So just put the value 1 and 2 initial final state. Okay, then you will get 1 minus 1 and 2 in the Rydberg equation. Okay, just you just need to calculate Z. Okay, the nuclear charge of the system. So this will get the Z square value, this, and Z value 7. Okay, so I'm not explaining, just see the calculation. Okay, very easy question. Okay, the film of stearic acid. Okay, so this is most of the students are telling me that this question is from liquid state. No, this question is from adsorption and Gibbs adsorption isotherm question, and this is the surface film problem. Okay, so in the surface film section, you will get in my material, there is a section called surface pressure. Okay, and this is the equation, and that equation I have used to solve this question. Okay, so this question is also came from my material, so that's also good. So what you need to do, you have to just put the value of surface pressure, and surface pressure per centimeter square is this, and this is in SI unit. Okay, joule is in SI unit, and they're asking the answer in the Newton meter, that is in SI unit, so it is given centimeter square. So everything is, you just need to play with the units. Okay, you just have to take care of the units. So surface pressure per centimeter square is this amount of joule. So per meter square I have calculated. Okay, divided by 10 to the minus 4, and that is at this value, and this is value in joule. So I have put the value in this section, surface pressure. Okay, then the gamma 0, that is for pure solvent, it is given. So I just need to calculate gamma for solution. So I have just calculated this, and I just got 0.047. This is the correct answer. This is not from liquid state, and this is the screenshot of my material from where the questions came. Next question, the dihedral angle. Okay, dihedral angle means the torsional angle, of course. So you just have to draw the plane, okay, where the first methyl group is present and the second methyl group is present. So this is a conformation type system. So you just have to draw the least energetic, that is most stable system, that the two methyl group will be trans when. Okay, so two methyl groups are in the trans position. That means this section, and the first plane is the above section, second plane is the below section. Above, below, the angle will be 180 degree. Just put the value. Next question is degree of unsaturation. So dBE, formula is this section. This is the given formula. So put the value of C means number of carbon, N means number of nitrogen, H means number of hydrogens, X means number of halogen. So put all these things. Nitrogen is 0, that is the system doesn't have any nitrogen. For halogen, the value is 0 because there is no halogen over here. So the value will be 9. So this equation is present in my NMR system. So the same equation is present. So you just have to equation. Whoever has read my material, they can easily get a lot of questions directly came from my material. So that's why I'm showing, so that you can believe that yeah, that is also possible, because these are what I read during my preparation and cracked the exam. Okay. So the number of lone pairs present in the phosphonic acid. So draw the structure of phosphonic acid, and in each of the oxygen atom, 2 lone pairs are present. So total lone pair will be 6. Okay. The number of value. Okay, so very easy question. The number of the valency of phosphorus is 5, valency of oxygen 2, -2, and over there is -6. So put the 5 into n, -2 into 18, and equals to -6. Calculate the value of n, value of n, you will get 6, and that is correct. Total number of protomers. Okay, different. I have drawn the structures. Okay, so see those structures and understand those. Next, Maxwell distributions. Okay, so this is the Maxwell distribution image. So in my material, you will find this kind of pictures, and this highest distance is called most probable velocity. Okay, most probable velocity. So they haven't given that the most probable velocity is this. They just gave the picture. So you have to take care of the pictures also, graph also. So that these image, the same image you will find in my material. So the most probable velocity, the equation is 2RT by m equals to 500. Okay, here also you just have to take care of the units, right? So everything is in SI. So put every values is in SI. So I have just put the values, then I have done normal calculation. So check the calculation. Okay, otherwise it's just wastage of time. Okay, so pause the video and check the calculation. I have done a detailed calculation. Next question, electrochemistry mathematics, very easy questions. So there is given the two values, Cu2 plus 2Cu, that I have told you the highest E0 value that will be cathode, and lowest value that will be anode. That is higher value that is reduction, lowest value that is oxidation. So here reduction will occur and here oxidation will occur. So that means reduction, that means copper 2 plus reduction, that will accept the electron, 2 electron, and the value is this. Zinc, that will release the 2 electron, that the value will be this. So after we get the same equation that is given in the here, that is given over here. So the equation, if we write in the ionic form, from this to this, we will get this. So this equation we have got this. So E0 cell will be cathode minus anode, or right minus left. Okay, so cathode value, that means this value, minus anode means this value. So total value we will get this, and after using the equation delta G0 equals to minus NF E0 cell, we will get the answer. Okay, so just put the value and you will get the answer. Remember, here they are asking about the value in kilojoule per mole. You will get the value in joule per mole. So don't forget to convert it into kilojoule. Okay, this kind of mistakes you can easily do in the exam. Okay, so this kind of question you can face in the numerical section. That is over here in my numericals. So 173 different kinds of numericals present. Okay, so check the numerical section. Okay, so for that just visit easychemics.com. Whatever, this is the very easy question. So you just need to know the formula of isoprene. Okay, so here the question is how many isoprenes are there to form this complex. Okay, the formula of isoprene is this. So that means 4 carbon in the chain. Okay, I'm not considering this methyl group, this is branched. Okay, no, you don't need to consider that branch. So just 4 carbon in a long carbon chain. Okay, so that means total 1 2 3 4 1 2 3 4, and like this I have got 1 2 3 4 5 6 chain, 6 isoprene present in the system. Okay, they are just 6 isoprene, okay, molecule is present in the system by linking. Okay, so the answer will be 6. Okay, you just need to know the formula of isoprene to answer this question. Whatever. Okay, so this is a Lambert-Beer's law, and you just have to put the additive property concept. Okay, just you can solve this question. Okay, Then this is a CO3PO2 whole tree. Okay, so they have given the formula. You just need to, you know, the Z plus and mod of Z minus, that is the positive value, and you just need to get the ionic strength value. So to get ionic strength, okay, that calcium 3 and phosphorus PO4 2 PO4 ions, PO3 minus ions, and 3 Ca2 plus ions are present. So the ionic strength formula is half summation of MiZ square. M is concentration, that is given 0.01 molar, and half 0.01 into 3. Okay, why 3? Because 3 Ca2 plus presence, and 2 plus means 2 square Z square, and they had also M 0.01. The PO4 ion, number of PO4 ion is PO3 minus ion is 2, that is value is 2, and the charge is 3 minus, that is mod 3, that is 3, that is 3 square. Okay, so after calculating this, I have got I equals to 3 by 20. I have put the value 3 by 20. I have got the gamma plus minus value, okay, from the equation, that is 0.066. And the same equation you can see from here, I have to calculate the ionic strength in my material, and the expression of calculating the ionic strength is this. Okay, so you can just get the mean ionic activity coefficient gamma I from this. This is the screenshot of my material. Okay, so this is the answer. So the next question is from titanium tetrachloride. Okay, to answer this question, read the question, pause the video, and to answer this question you just need to know the reaction. So this kind of question you can easily face in IIT examination, because they will not allow you to get 100% marks. Okay, so the answer product will be TiCl4.2THF. So you just need to find that from 5 gram of TiCl4, how, if the yield is 80%, how much product you will get. Okay, so molar mass of TiCl4 is 190, molar mass of TiCl4.2 of THF, that is 334. Then you just have to, that means from 190 gram you will get 334 gram product. From 5 gram you will get this amount of product, and this is of course should be 80% yield. That means you have to multiply it 80 by 100. I have done this and I have got 7.03 gram. That is the answer. Normal mole concept problem, but you just need to know the product. Okay, here this is the trick. The same question is bacterial growth. So remember this one, bacterial growth is a fast order kinetics. Follow the fast order kinetics, and from mother cell in 20 minutes they just 2 daughter cells are produced. That means you just have to use this equation twice. Okay, so in the first case I just need to calculate lambda, that means rate constant. Okay, kinetics constant. So just put, so n0 is 1, that is initially, nt is 2, that is 2 daughter cell, and t is 20 minutes. So put the value, you will get this value, the lambda value, rate constant value, and in the second case just put the lambda value to get the time when a number has concentration. Both are equivalent, of course, concentration is equivalent to number in that kind of equation. Then put the value of C0, that is initial concentration, that is 5 centimeter cube, 5 centimeter to the minus cube, and Ct at time t, that is time, of course I just need to calculate that, 10 to the power 4. Okay, so put the value and you will get the value 17 minutes. Okay, this is very easy question, just use the chemical kinetics equation. The next question that I have got, so you just write the equation. Okay, the formation of MgO, I have written the equation. So remember this one, you just need to get 1 mole, because the value delta HF is given this value per mole, so you just need to form 1 mole of MgO. Don't balance it like putting here 2 or 3 like that. Okay, don't do this, you just need to get 1 mole of MgO. Okay, so after that I just calculated the delta H value, because I know to calculate delta G I just need delta H minus T delta S. Delta H is given, so I just need delta TS, delta S. T is given, so I just need delta S. So delta S I will get from this. Cp is not Cp, you don't need Cp over here. Okay, they are just giving you to confuse. Okay, so just get the delta S value, that is product minus reactant. Okay, so you have to multiply also the stoichiometric coefficient, that means delta S of MgO, product minus reactant of this. So put this value is 0, this value is 0, and just half into this value. So I will get delta S equals to this value is in joule, so convert it into kilojoule, because delta H is given in kilojoule. Okay, so to do the calculation you just have to convert it into kilojoule per mole. Okay, so put temperature, delta S, I have put all those things, then I have got the delta G value. They are asking, remember you just need to play with the units, so they are asking about the answer in kilojoule per mole. Okay, that's why the answer will be minus 572 kilojoule per mole. The next question is about the, very easy question, read the question, and this is the osmotic pressure question. So you just need to use the equation and you will just need to play with the units. Okay, this is very famous. Okay, playing with the units. So phi equals to CRT. C is given. Okay, the unit of C is mole per liter. R is given 8.3 joule mole inverse Kelvin inverse, and temperature is this. So I have got all those things. I have got 8.3 and 300 and the Newton meter, the left unit. Okay, Newton meter and liter inverse. So here it is given that 1 bar equals to 10 to the power 5 Newton per meter square. That means 10 to the power 5 Newton per meter square, that is equals to 1 bar, and 8.3 into 300. Okay, so Newton meter, and I just need to convert this liter inverse to meter to the power minus q. Why? Because here its meter is present. Okay, just convert it. So 10 to the power 3 meter cube. Okay, so how this calculation is present? So you just need to learn that 1 liter equals to 1000 cc. Cc means centimeter cube. So from centimeter cube convert it to meter cube. So it's quite easy. So for 1 liter calculate the same. Okay, so just put the value and then we'll get value in Newton per meter square. So from Newton per meter square, divide it with 10 to the power minus 10 to the power 5 or multiply it with 10 to the power minus 5, then it will be converted to Newton per meter square to bar, and that will be 24.9 bar. The answer, correct answer. Okay, just here nothing is present, you just need to know the formula and you just need to play with the units. So that's all about this question. That's the whole solution of IIT JAM 2020 chemistry examination. That only on this channel you will get all these solutions in one video. So I hope this video will help you. If you want to get the materials, you can WhatsApp or call me on this number. Okay, and if you want to get all those things, you can just visit this website. You will get everything, every materials. If you want to join the online test series, you can call this number. Of course, you can visit this website. Okay, but remember one thing: don't waste your time. Start your preparation now. If you are thinking that you want to prepare for IIT JAM chemistry examination, right? And also, if you practice a lot of questions, that is, if you start from now, then it will be very, very helpful. Otherwise, you know that it will be very tough if you are starting from 2 months or 3 months later, because your competitor already has started their preparation. So don't waste your time. Remember, more practice, less will be the rank. Okay, so that's all about this video. I hope this will help you a lot, and thank you. Thanks for watching.